Hi guys, so today we are going to solve a sum called as climbing stairs. So this seems like a pretty easy sum and people say this is an easy sum, but I kind of found it still confusing. But I'm going to tell you what I took as an approach, so you can watch this video and this guy tells us exactly
Exact same
what
thing that
we're
we did, right? From
supposed to
here, we
do.
can take one step.
Okay, let me tell here. So he's created a graph like this. Okay, we want to create a graph bottoms up because this is an inverted graph, and we want to go from all the way to, if n is equals to 5, then we want to go all the way to from 5 to 0. Okay, so and we want to use memoization as well. You already know what is memoization. If you don't, please check out any other videos for that. All right, so
So we're going to have a position in DP all the way from index 0 all the way up to index n, which is going to be our input value, remember? So remember, we're at the base case initially, right? What's the base case going to be? Well, at the last step, if we start here, how many different ways can we land here? Well, that's just going to be one, right? That's our default value. So now that we solved that, we are able to solve this one, right? Because remember, this problem depends on the subproblem of this. So from here, let's say we're starting here, we can take one step, which lands us at the result. We can take two steps, which lands us out of bounds, right? So how many different ways from here can we reach the goal? Again, it's going to be one. And you notice how this is always going to be the case, even if we had something like n equals 100, so let's say this was actually 100 and this was 99, this would always be 1, right? This is always going to be 1 because it's at the goal. And starting from here, it's also always going to be 1 because we can take one step, which would get us to the result, or we can take two steps, which would get us out of bounds. So no matter what the input value n is, this is always going to be the case. It's always going to be 1, 1. Next, we're going to get to the interesting part. So then we want to know, okay, how many different ways from here can we reach 5? Well, this depends on two subproblems which come after it, right? So we can take one step over here or two steps over here, right? And then we get to the subproblem, right? So from 4, we don't need to continue to figure out how many different ways from 4 can we get to 5 because we just computed that. That's why we're using dynamic programming. That's why we have this array because we already
okay, so this is the thing, and we don't want to maintain this whole array basically. Okay, so 1 1 and 1 plus 1 is going to be 2 and 2 plus 1 is going to be 3, 3 plus whatever, this is the Fibonacci series. Okay, so basically what we want to do is we want to know only the last two elements to find out the next element. So that is the reason we are using this particular approach. Now let's go to the Fibonacci series. Basically what we want to do is, let's say the number is 3, right? So there's a very simple solution to this. I will show you that as well. Okay, so basically let me actually show you. Copy. 1 second. Yeah, this is the one. Yeah, this is the solution that I initially incorporated, but this does not have the memoization implemented, therefore we want to make it bigger. So basically what we are doing is, if n is equal to 0 or is equal to 1, we will be returning 1 as we saw in the explanation. So it had 1 and 1 over here. Okay, and rest of the elements we are going to take the last element and take the last of last element, and we're going to add them and we're going to give the result. Okay, so this is a very simple explanation. Now basically what we want to do is we want to add a map over here. Okay, we want to add a map over here, and we want to store each value in this. And if you have already stored, if we have already calculated that value, we will directly get it from the map. That is the simplest explanation I can give you guys. Okay, so let me show you. So I've got a map in here, remember the syntax, and then if it is 0 or if it's 1, we can return 1 directly. If it is not, then we have declared first and second as the variables, integers, and then if for the first integer I'm going to check if that particular value is present or not. If it's not present, then basically, if it is present, basically we will just pick that value. If it is not, then we'll calculate that value and then we'll put that value in the hash map. Similarly we do for the second one, and then we're going to add both of them and return them. So this we have solved with 0 ms and 100% beats. Okay, so that's it for the video today.